Hi, today we are going to discuss about latch-up. What is latch-up in the CMOS transistors? So in the fabrication of CMOS under N-well or P-well or tin-well, there is a possibility of latch-up. So this latch-up is a formation of parasitic bipolar transistors that forms a thyristor structure inside the CMOS transistor. So once the thyristor gets enough biasing, then it makes a small amount of circulating current which flow through the substrate. This will be called as latch-up. So now we will see how the thyristor structure will be formed inside the CMOS transistor. We know that thyristor is a SCR or thyristor. It's a four-layer device. It's a four-layer device, so it will be P, N, P, N. It's a four-layer device. So in this, if you divide this four-layer device, if you cut into this, then it becomes P, N, P. So now we can model this into P, then two halves of N and P, and the bottom again N, and there are two here. So one is P and this N. So these N gets connected and P get connected. So we can get one PNP transistor and one NPN transistor. So we can analyze the thyristor into two transistor analysis. The one is PNP transistor, another is NPN transistor. It's similar again, a thyristor structure. So we can model this. This becomes emitter, base, collector. So here also emitter, base, collector. Emitter, base, collector. So now we can model this one PNP transistor in a bipolar. So PNP transistor. Another one is NPN transistor. NPN transistor, this becomes your emitter. And this collector and base. This base, NPN transistor base is connected to collector of the PNP. And similarly, this collector is connected to this base. Okay. Then, if we apply enough potential between these two, and similarly these will be coupled, these transistors also biased to some potential, then this structure becomes biased. So now we will see that how this structure will be formed inside the CMOS transistor. So this is called as SCR. So in SCR, it is modeled with now two transistors, and once the SCR it gets enough potential, initially the current in the SCR is 0. Once it reaches the enough potential, then suddenly the current through the SCR gets increased. So this circulating current, it flow through the CMOS transistor substrate, then it will heat up the device. So how we can avoid this latch-up, how it will be formed inside the CMOS, and how it can be avoided, now we will see that. So now we will take one transistors of CMOS, either in N-well or P-well process. So first we will take one substrate. So now we will take N substrate. So over the N substrate, a P-well is implanted. Over the P-well, we will create NMOS transistors to N plus. This is also N plus. And to avoid the body effect, here P well here your conduct will be created. Similarly, over the N substrate, normally we used to create a PMOS transistor. This is P plus, this is another P plus. Then for the substrate connections, we will have a substrates here, substrate contacts, and this becomes source, and this becomes drain. Here also NMOS, so drain, source. So these two will be connected, and normally here it will be the gate. So normally SiO2 under here, under CMOS transistor, this gate will be connected, this will be connected to VN, and normally this becomes output connections, and these two will be coupled, and similarly these two will be coupled. So NMOS, no, so here it is drain, this becomes source. So now we will see how the parasitic bipolar transistors will be formed. So in that we need one NPN transistor and another one is PNP. Always NPN or PNP, that base terminal will be always substrate. This base will be substrate. So one base required P, another base required N. So here the substrate we have one P well and one N well, or one N substrate. So here this N substrate will act as a PNP transistor. It is the base for, here N is base, so here we are going to form PNP transistor because N base here, and similarly here we are going to take P base, so we are going to form NMOS transistor, sorry, NPN transistor. So always this becomes P. And what is this another is, so base is this one and emitter will be this substrate. So here PNP, this is PNP transistor, so these two contacts, so here it will act as a P, and this will be normally connected to here. So this P, so P, N, P. So this P is taken from the source substrate contact. Another P is taken from the well of this next transistor. And similarly for this NPN transistor, this one, so N is required, here N is required. This N will take from the substrate contact. Another N will be this collector. Collector will be taken from the substrate, this substrate. So as per the SCR structure, one PNP transistor and one NPN transistor, and this collector will be coupled to base, this collector will be coupled to this base. Similar structure here, always the base will act as a substrate and these collectors will be connected to this base and this collector is connected to this base. Now we are connecting here, here we are connecting a VDD on the drain, and sorry, now we will connect here VDD and here it will be connected to the ground. So now because of the potential applied between this source and this drain, this thyristor gets enough biasing voltage. This thyristor inside this PNP transistor and NPN transistor, it gets some biasing voltage through this substrate resistance. The substrate will have a own resistance, so the body voltage here, because of the source and substrate is connected, this makes some potential drop in the substrate. This substrate is enough to create some biasing potential to this bipolar transistor. Similarly, this transistor also will provide some biasing voltage through this resistor to this NPN transistor. Once these two transistors gets some enough biasing voltage, then it makes a thyristor structure. Then there is a circulating current which flow from this transistor to this transistor. So once the circulating current which flows through the transistor, normally it will heat up the device. So this will be called as latch-up. So once the device heat up, then it's a possibility of damage of the device. So we need to avoid this latch-up. How to avoid this latch-up problem? We should avoid the formation of the thyristor connections. Anyhow, once we form a CMOS transistor in N-well or P-well, definitely this BJTs will be formed. But we should avoid the connections between these two transistors. So then only this thyristor structure will not be formed. So how to avoid the connections between these two transistors? So one way of avoiding the connection is trench isolation. One method is trench isolation. What is trench is, we need to create a small trench between these two transistors, N-well and P-well, NMOS and PMOS transistor, by means of photolithography process. This small trench, it will be a micro or nanometer gap, and this gap will be filled with silicon dioxide. So silicon dioxide, you know that it will act as a insulating medium, so that the connections between this NMOS and this NPN and PNP bipolar transistors are being avoided. This is one way of avoiding the latch-up problem. Another method is increasing the doping level of substrate. So what will happen if we increase the doping level? So doping level increases, automatically the resistance decreases. Once the resistance decreases, the voltage drop in this substrate resistance, it is not enough to make the bipolar transistors to get turned on. So once the drop is less, automatically this transistor will not be turned on. This is another way to avoid the latch-ups. So the third method to avoid these buried contacts. What is buried contact is, again it will be used to reduce the substrate resistance. Very high diffused layer of the same, suppose if it is N substrate, here N plus, highly concentrated N plus is diffused at the bottom of the substrate. So this bottom of the substrate, it becomes very low resistance because it is being highly concentrated, and it is coupled parallel to the low resistance, low doping substrate. So what will happen if you make one high resistance parallel with a small resistance, the net resistance becomes very low. So automatically this buried contact, it makes the substrate resistance to the lower value. Once the substrate resistance becomes lower, automatically these transistors will not get the enough biasing voltage, so this latch-up will not be occur. So in this way we can avoid the latch-up problem in the CMOS transistor. Thank you.